Hello and welcome to C++ Weekly. I'm your host, Jason Turner. I'm available for code reviews, contracting, and on-site training. Now, I am starting the fifth episode in my C++ Weekly game project idea. Now, I've made a couple of decisions. One is that I need to do like all of the foundational work that I can. I really want to get this in a state where anyone can take this project and fork it and not have a game, but have all of the tools in place that they need to create their own game. And then once I have done all that foundational work, then I will apply my own game to it. So I'm going to do a little bit of reworking of the plan here, which we'll take a look at right now. So I've got the plan. That was episode 0. We've done that. We've done getting started, finding errors as soon as possible, handling command line parameters. Now, episode number 4 here, the 5th episode, should be C++ 20 so far. But, so at the time of the recording of this episode, GCC 10 was just officially released, like yesterday. And I decided that I'm going to push off this question of what exactly C++ 20 will give us for at least a few more weeks in these episodes. And instead, I'm going to talk about reading input states. Now, I'm going to split this up. So let's just go ahead and see what this would look like. Okay, so this is my set of to-do items here for our plan. The plan, getting started, finding errors so far, finding errors as soon as possible, handling command line parameters, C++ 20 so far. Okay, so this is what I'm going to do. I'm going to do this, I'm going to do this, and what we're going to do is actually deal with this as several different things. We're going to deal with reading SFML Joystick or Gamepad. It's called Joystick in SFML. Oops, not Joystack, Joystick. And then we're going to deal with keyboard, mouse. And as far as the devices on this computer go, I am going to deal with also touchscreen. Now, I think that reading the touchscreen states is going to be actually very interesting, partially because I'm running this on a virtual machine and I have no idea what happens if I pass over the touchscreen driver to the virtual computer. We may have to run that part of it natively on Windows, which is perfectly fine because this project is in fact cross-platform. It's just not well tested on other platforms yet, but the continuous integration builds, I believe, are working at this point for Linux and Windows and Mac OS. It'll be something to double check at some point in the future. So, the touchscreen states. Now, I like to play puzzle games that really work best with the touchscreen. So, I am hoping that I will be able to, in fact, use the touchscreen and make that an aspect of the gameplay that's available to us here. Now we're also going to some point outgrow this file. At this point our main.cpp is quite small, but by the time we're handling all these different states, we're probably going to want to split this stuff up and make it all a bit more maintainable. So this is now what we are looking at, and let's see if I learned I did not learn the correct keyboard shortcut. Shift F10. Okay, I'm working on this. Now see the syntax error that I'm getting here at the moment is coming from CBP check. CBP check doesn't know how to deal with the C++ 20 ranged for loop syntax. So this is where we are. We've done the plan, getting started, finding errors as soon as possible, handling command line parameters, and now we are going to read SFML joystick states. If we continue to get this error, let's see. This is from our static analyzers here. We probably want to pass something to disable, specifically, let's see, suppress, -- suppress, equals syntax error. I don't care if CVP check can't handle the syntax of what I'm doing because CVP check is like a secondary static analysis tool for me, and I'm going to be using syntax that almost certainly it does not know. Let's go ahead and do a build, which will change everything. It's interesting because now I'm not getting the syntax error from it. So we are just going to move on from this, and we're going to talk about what we need to do in our main.cvp. So now we have two different things. We have events coming in, and you can see that we are polling those events right here. And we've got the current real-time state of the joystick. So I will clarify the difference between these two things. So when we are in this event loop, we have this handful of events that come in. We're going to focus on these events right here. We get a joystick button event, which is a button pressed or a button released. We get a connect event, which is joystick connected or joystick disconnected. And we get a move event, saying that the joystick moved. Now, if you look at any one of these individual events, we'll see things like this is the axis, this is the new position. Button event, we get which joystick ID, which button has been pressed or released. And if we get a connect event, then we get joystick ID that was connected to the system. Okay, so I have never worked with this joystick API with SFML, and if you're following this series at all, you should understand that I really have no idea what I am doing. So this is a fun adventure for everyone, but it's what I promised that I would work on, and it's what I've always liked the idea of working on. So we'll see what we find. Okay, so let's just start with this joystick connect event. This is let's do a switch. Yes, indeed, 23 enumeration event values not handled in here. So that's, well, we'll get to that. Now, we want to have this event joystick, and this is, I mean, you know, this autocomplete stuff is pretty awesome. And given that I'm, you know, really just now getting back into IDEs, I continue to be kind of impressed by this. So let's say a joystick connect event. When this happens, now we've got our logger. So let's just start with this logger, speed log. We've got a default logger. Now we'll play with the logger more as we go in, but we've got just the default kind of global logger here. And we will do a debug event saying and this uses lib format as its underlying thing, so this is super handy. Now, we need to actually get access to this underlying event here, and this is going to be a joystick event. It turns out that we have this union attribute here, which is an anonymous union. So I should just be able to say event.joystickConnectEvent. Joystick connect event, and I can get the joystick ID. So let's do that. We'll say that we have a joystick connected. Get rid of that. We don't want fall through. There we go. And I'm kind of curious about the name of this joystick. So I'm going to do this here. Now, if you're not using lib format or any of these awesome modern formatting things for C++, then you really need to start using them. So SF joystick, this gives us some like real-time joystick information here. Let's make sure we get this API right. So this SF joystick gives access to the real-time state of joysticks. This is in the joystick header. It is SF : joystick. So it has static functions. These are all static functions. So I got this, I want to do this get identification. Get identification of joystick. Now, at some point this becomes a little silly, but this is what we want. We want the identification and we want its name. All right, and then we break. So now we should know if a joystick has been connected. Let's make sure we get this right here. So this is a joystick connected event specifically. There we go. So now we expect to see a log message when our joystick is connected. Let's see if this works. Now this is still telling us that we haven't handled all the enumeration values. But we're not going to worry about that at the moment. So I press play here. Now let's see what we have. Okay, so I'm going to get this because I have warnings as errors. Warnings as errors does get, prototyping kind of in the way here. I don't like to have default cases. I'm just going to do something at the moment here so that we can get moving with this. So this is fun. We did get a compile error here. Main.cpp line 92. This is telling me that it cannot format whatever it is that I passed to it here. I'm getting this error from format v6. So what is the error? What is name? Name is a SFML string. And what is an SFML string? It is not a standard string. It is not something that our formatting library knows how to handle. So do we want UTF-8, UTF-16, wide string, etc., etc.? Let's do that. Definitely a little bit of a mixing of character types is disallowed. A little bit of a learning curve here for working with SFML's string and what the rest of our system expects. So I really just want, if at all possible, a C string kind of const character pointer, something like that. So I see this log message here. And I'm not getting any of these unhandled event types. Let's see what happens if I can get this actual joystick pressed message. Okay, I'm not getting any of the debug messages out that I'm expecting to get. That tells me that my debug level is not set where I expect it to be set. So let's see what's going on. Error and info messages. Let's set our default log level here. So off critical trace, warn, I'm going to put it on debug at the moment. We can use trace later, perhaps. Okay, now we're getting these mouse move events happening as we go over it. And that is a little bit annoying. We did not see a joystick connected event. So I'm going to disconnect and reconnect the joystick and see what happens. There we go. Perfect. Joystick connected, joystick number 0, Logitech gamepad F310. That is exactly correct. Okay. All right, these things are fun. So we now know that we get all of these things. Let's say unhandled events become trace events, and joystick connected events we get a message about. Now I had to do the static cast to the stood string so that speed log could deal with it. Now I can add my own formatter for SFML strings, and I'm probably going to need to do that at some point. I'm not going to at this exact moment. So we get joystick connected, and then we should be able to also get joystick disconnected. We want to know when it's connected and disconnected. Those are important things. Now we also want to be able to track the button state. Now we've got multiple ways of dealing with this. Do we want to know every single event that occurs with the joystick, or do we want to only know the events that happen at the moment when we can? So this is the polling and processing of events. This is the update of the screen of the clock, and then this is where I am doing the actual window stuff. So now in this point down here, I can read the real-time state of every joystick, or I can read the state purely through the events that happen. Now I might need to do a combination of both of these things. The disadvantages are that if I have reading the poll events here, then I have to kind of keep track of when the event started and when the event stopped. So let's look at that. If I look at this event class, it doesn't tell me the time. So if I know that the game player pressed the jump button, but I don't know how long they held it down for, and then they released it again, then that's not terribly useful to me. If it was both pressed and released between frame updates, then what in the world am I supposed to do with that information? There's not a whole lot I can do with that necessarily. I might still want to make the character give a little hop or something, but yeah. I think I'm going to be more concerned about the real-time state of things, but I kind of need to know both of them. So if I know that during this frame that I'm processing there was no new button pressed down, that it was the same button that was pressed this whole time, that's less state that I have to keep track of myself. So I'm going to try to just at least get some sort of model built up here that is the current state of the joystick, I guess, because these events are coming in regardless. I have to discard them or process them. So let's see. Okay, so we've done a few things now that I both like and don't like. So I'm going to run through them real quick. Now I probably just sped all that up that I just did, and probably, several times speed in my editor here. But first of all, I had some code that was duplicated. I removed the duplicated code. So one of my main rules for good C++ programming is to never copy and paste code. And it's a rule that applies really to any programming at all. So I gave myself a couple of helper functions here. Load joystick and joystick by ID. Now the idea is whenever I need to access a joystick for an event coming in, I call this joystick by ID, and it checks to see if a joystick with this ID has in fact already been loaded. And that is based on the vector that is passed in. Now, there's a couple different ways I could have done this. I could have put them in a sparsely packed array where I just have all the joysticks of all the maximum IDs always in memory at once. And I decided that's not a great idea because I never know how many joysticks are actually in use. The other problem that I'd have with that is I don't know who player 1 is supposed to be necessarily. So with this way, whenever a button is pressed or something on a joystick for the very first time, or the joystick is actually, I probably don't even want the joystick connected and the joystick disconnected events necessarily. I will need the joystick. No, maybe I don't even want the joystick disconnected event. I'm not sure. So I don't know if we've got multiple players. I'm not sure how this is going to play out exactly, but I can easily get the joystick that is next, whether or not it's been loaded, and I can use this if-else branch here. Now this is actually interesting. First of all, I don't like this clean tidy warning of do not use else after return. I prefer this code, but it gives us just a moment to play with. Well, no, we'll play with that later. Never mind. I'll just leave you hanging on that one. So I've got this code that can load the joystick, can store it in the array, and I can keep track of all of the different button states and axes. Now, this one I'm a little confused on because I am storing a bunch of integers for axis count. Now, what I don't know is exactly how this axis joystick data is stored. Let's look at that. So the max number of joysticks supported is 8, the max number of buttons per joystick is 32, and the max number of axes is 8. So then I've got these values, X, Y, Z, R, U, V, POV X, POV Y. These are the axes that are supported. Now it doesn't tell me what type of value this is. Like, are these assigned 0 through 7? It's not even, it's taking me to where I am. So let's see if we can jump to the actual file. Yeah, okay, so the max number of axes is 8, and they do seem to be stored in this way. So I think that this makes sense, although it doesn't quite give me a type safe index operation here. I don't know, we'll play with this, and we're almost certainly making design mistakes that we'll regret in the future. But when I get a joystick connected for the first time, I load its name, I get its ID so that I can use this ID information later if I need to, and I store it here. Now, maybe it makes sense, again, to store this in an array instead of a vector, but I kind of liked the idea of knowing what order the joysticks were first used in, so I know which joystick the game player wants to use. Then that's always going to be the 0th one, because I feel like processing these events, this is not going to be the expensive part. Actually deciding what to do later will be the expensive part. But this is all new to me. Now at some point we start wonder maybe if I should just use a variant and push these into a variant, but I definitely will have to disable this warning around this code at some point because I have to use a union member to use this library at all. This is the kind of real world thing that people are going to run into, I think. I keep doing this. This is easy to do here. So this is a button pressed event. And then I need to say that the button indicated to the joystick button event. So this is not Kinect button. Button, there we go. So that is currently pressed. Except that shouldn't be const auto now. Now, one reason that I'm going down the road that I am at the moment is because I fully expect to want to abstract this out just a little bit more, because I had stated before that I want the ability to be able to do this in both SFML and in well, any other UI library that you might want. So this is kind of a little bit more generic that I'm pushing it into my joystick object here. But we're going to have definitely some questions that we need to answer. Oh, goodness gracious, I really don't know. Joystick. Oh, right. It's the capital joy. Capital joystick, move. Moved. There we go. I see. All right. So joystick moved. That's the joystick move event. All right, fine. And now which axis? Yeah, I think there's several things we're going to end up regretting here, but it's a start. It's a start. I'm thinking ahead. Oh, position is actually a float. All right. Now, let's see, position. That's the axis. Position. And that's a float. All right. Now, things that I'm thinking that we're going to regret. Now, if there's a bunch of events coming in all at once for the same joystick, then I'm having to do this joystick lookup every single event. That doesn't make a whole lot of sense. But then again, if there's a bunch of events coming in for several different joysticks out of order, then paying the cost of trying to aggregate the events could actually be more difficult. Now, the other problem that I have is, like I said before, with this existing code, as I've written it out right now, we might have the case where I miss a joystick event. If it was an important one, I don't know. I may have missed it. So that could potentially be a problem. Yeah, so I'm getting this that I want to use .at instead, so that I don't get the possibility of a going off the end of this array here. I think this is pretty safe because I'm using compile time constants provided by the library to me. So I think this is going to be okay, but this is another reason to have our analysis turned on. So we're getting some yellow squigglies here. So we've got a handful of things. We're probably going to want to simplify this. I'm probably going to stop right here now, though, because this episode has been going for quite a while. Yeah, at the moment, I have been recording for 52 minutes. So this will definitely be edited down for your consumption, but let's just see what we've got. I want something to tell me that I have had a joystick event. So this is going to be a little bit of debugging at the moment. I'm going to create a new window. Yeah, I think I know how I'm going to do this. I'm going to do this. It's going to be really, really simple for the moment. I don't need that joystick event. Maybe I do. Okay, yeah. Just going to show whatever the first joystick is, because like I said, I want to wrap up this episode. If the joystick list is not empty, then I want to make a checkbox for each of the buttons. We can do that. So at some point, we're going to want to come back here and clean this stuff up too, because I don't want to do this .c string nonsense every single time. So I might make my own checkbox helper that just uses format. That would be really, really quite awesome, actually. Oh, but this has to be, shoot, it has to be mutable. And that doesn't make any sense. I don't want to be able to change this thing. So checkbox, that doesn't work. That doesn't work at all. There we go. Unformatted text string. Maybe we can get this going. Oh, I left the thing running the whole time. Of course, build failed. Joystick effect set but not used. Yeah. Don't need those. I don't really care until the game player presses the first button. Oh, well, that's clearly a bug, and I should have noticed it before too, because I wasn't getting a comparison thing here. Good thing I used const and it caught that bug. Okay, all right. So I only have one joystick. It says that we've got joystick events because I'm not resetting them. All right, that's button 0, button 1, button 2, button 3, button 9, button 10. That's what's happening if I'm pressing in my 2 axes. 4, 5. Those are axes. All right. Back, start. So I've got 1, 2, 3, 4, 5. No, 1, 2, 0, 0, 1, 2, 3, 6, 7, 9, 10, 4, 5. All right. All right, those are my 10 buttons now. All right. All right, that was a bit long, but that's where we are. We can now read the joystick state out and at least put in some sort of debug messages. I am going to stop here. I have no idea how long this episode's going to be. When I am done editing it, we're going to end up with something like this. Now, this is great, I think, because it gives us a foundation. We're going to start reading the keyboard events and the mouse events and all those kinds of things so that we can work with those other things if we want to. And I'll fix up these bugs as I can along the way. So thanks for watching this episode of C++ Weekly. I will be sure to tag this episode as well as episode 4, and you can go and check out the changes that I made on the GitHub. So thanks for watching.